Hi, in this video, we are going to run a time series model using auto time series. Auto time series allows you to run multiple models against your data. These models can be from Facebook Profit, or it can be an ARIMA model, or a seasonal ARIMA, vector auto regression, or even a typical machine learning model. All this can be done in a couple of lines of code. So what we are going to do in this video is we are going to take a data set, quickly visualize the data set and feed it to the auto time series package. Auto time series package will internally run your data against multiple time series models and give you a leaderboard on which model perform better. And what you can do is you can pick a particular model of your interest and then use that particular model for forecasting future values. So let's get started. So for this video, what I'm doing is I'm installing AutoTS package. This is part of AutoVML package, which is in GitHub. I will show the GitHub link as we go into the details when we come to the modeling side of it. And then there is also a dependency which is currently missing in the AutoTS so that we can install separately pip install tscv. But I think it should be fixed and it should be part of AutoTS over the time. So these two packages I have already installed. Then what I'm doing is I'm importing a set of packages, pandas for importing the data, matplotlib for visualizing the data, plotly express as well for visualizing the data, and the auto time series package itself. So what I'm doing is I'm telling from auto_ts import auto time series, and auto time series is what we are going to use to run our models, right? So let me run this, and the data set I am using for this purpose is in my GitHub repo. It is the New York City energy consumption data set. And what I'm doing is while I'm reading the data set, I am also telling past dates equal to true. So if there's a time column, it will automatically convert the time column data type to date time. Otherwise, it will come as object. And I'm telling the index column equal to 0. So the 0 column in this data set is basically your timestamp. It will just index the data frame based on the time column. So once I run this, you can see the output, how it looks like. You can do so. The data set looks like, you can see basically there are three columns: demand, precipitation, and time temperature. And timestamp column is also there, but it is indexed. That's why it's showing in a different order. So data is indexed by timestamp, and we have three columns over here. I can quickly run an info to what I'm doing is I'm resetting index, so that way timestamp also becomes a column, and I am running info to see the data type of all the columns. I am having timestamps as data time, date time, because I have given past date equal to true, and the other column as float 64. Now, what I'm going to do is I'm going to quickly plot the data. And for plotting the data, I'm using Plotly Express first. But the reason I'm using Plotly Express is I can create multiple buckets of the data, and it will allow to quickly visualize at one shot by dragging and dropping the slider. And how to create that? This is the way. So what I'm doing is I'm using Plotly Express line method. I am passing the data frame object. In this case, the data frame is indexed. I am just telling reset index to remove the timestamp and make it a regular column. I'm telling my x-axis as timestamp, y-axis as demand, and just giving a title over here. And then I'm using this figure object to update the axis. In the update axis, I'm telling create a slider object equal to true. So it will create a slider object basically at the bottom of the graph. I'll show you when we run it. Once we run it, let me run this and talk about the remaining. And then what I am also telling, I'm giving a range selector. In the range selector, what it will do is, let me go on the top. In the range selector, I am creating basically a 1 year range, 3 year range, 5 year range, and all. So what this is going to do is, if I total like say like 5 years of data. If I want to see only 1 year of data, it's going to, the step mode backward will take last 1 year of data and show it to me. The step mode backward for 3 years will take last 3 years of data and show it to me. So if you see, I run this is how it looks like. You can see basically on the top, I can see 1 year, 3 year, 5 year, and all ranges. By default, it is highlighted all ranges, and you can see a slider on the below. Either I can narrow my slider and go to a particular year range. This is one option. The other option is I can just select, okay, if I want only 1 year of data, I can just select 1 year. And if you see the 1 year graph from September 2016 to 2017, you can see during the month of November all the way till May, the energy demand is low compared to July till September. You can see basically it is increasing over here. If I go to 3 years range, you can basically see the same thing from July to October and all. It's kind of in the increasing pattern. Otherwise, like it's in the decreasing pattern. Maybe the summer months in this case have lowered. The winter month have lower demand, and the summer months have higher energy demand. So there is some kind of pattern seasonality that is repeating. So if you see 5 years graph, you can see like the pattern is repeating every year. So there is some seasonality in this data, in the energy consumption demand data. When you click on all, you can see all the data that we have data from 2012 to 2017. So this gives you a handy function to quickly slice and dice your data, go and look at a particular instance. You can even add legends over here so that you can highlight and see, like I didn't add temperature, but you can add temperature as an highlighter. When you click here, you will see when the demand was high, what was the temperature. You can do that as well. It's pretty easy with Plotly X Plus, right? So this is how our data looks like. What I'm quickly going to do is basically I'm going to, if I want to aggregate, so year over year, I have data point close to around like 49,205 rows. And when you're running an auto ML model, specifically ARIMA, seasonal ARIMA, WAR model, it will take a lot of time with this huge data. The data is at hourly level. If you see every hour, I have an observation. 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. So in order for me to reduce the footprint and just for this video run it quickly, I can resample it. What I can do is I can just say the data frame dot resample to monthly. So it will aggregate all the data at month level, and it's going to aggregate based on the mean of the data. And then I'm just telling plot how it is over here. So to quickly see how the data looks like. So I have very few observations to visualize here. Right now, if you see, this is how my monthly aggregated data looks like, and you can see the same pattern. The demand has some kind of seasonality, and if you see the correlation with the temperature, when the temperature increases, the demand also increases. That's what you can see every year. And the reason is when there's a summer month, the usage of your maybe the energy is also higher compared to the winter month. So you can see that pattern. There is a correlation between your temperature and your demand. All right. So this is how the data looks like. Let me quickly check if there is any null value or something, or what is the column names. I'm just having some selected prints. This will tell the number of rows, columns, what are the features are there, whether there are missing values or there are unique values. So once I run this, it's going to tell like there are 49,205 rows, 3 columns, and these are the 3 columns. Timestamp is also a column. It is not showing because it is indexed, but when you're modeling, you want to kind of reset the index and then model it, right? And then it's telling missing value is true for demand, missing value is true for precipitation, missing value is true for temperature. So all of these are missing value, right? And how many unique values are there? Demand has 40972 unique values. Everything is unique. Similarly, it shows these values, right? Now I need to impute this data before feeding it to the model. The auto time series package does not take care of imputing the data, right? So the first thing I need to kind of quickly query, and I'm checking that demand not equal to demand. It will show me all the null, right? Typically, when I say demand not equal to demand, any null values will show up because one null is not equal to other null. Typical SQL, if you know, you will say like where data is not null, you will not say equal to null. It's the same way data frame also. So when I say this, it's going to show me all the null values. And if you basically see, you will get a quick idea of null values. These are the null values, and looks like there are 81 rows that are null in the demand column, and this is how the data looks like. Typically, when it comes to the demand and temperature, the demand does not vary compared to the previous demand much, right? It's not that you're going to suddenly see spike completely. There may be spike during the night time and daytime, but not as much than the previous hour. So what I'm doing is here I'm doing a quick fix to just go to the model part of it, but you may want to run your own domain knowledge and do the imputation. But what here I am doing is I'm just going to use the demand and temperature column. AutoTime series supports both univariate and multivariate analysis. So here I am you going to use demand and temperature, both columns, to predict demand. So first thing I'm doing is I am filling the data, and how I am filling is I'm telling method forward fill. So it's going to take the previous hour data. Hours is hourly data. It's going to take the previous hour data and fill it in the next hour as well. So that's what it's going to do. So I'm going to do the same thing for demand and temperature. I'm just doing a forward fill. So once that is done, the data will get filled, and then I am creating a new data frame. I am resampling it to monthly level with mean, because I don't want to take 50,000 records and wait for my time series model to finish after an hour. You can run it with the daily data. It will take some time. For this video, I'm just aggregating to monthly so that we can see the output in a shorter time. But I would suggest you maybe take it at a daily level or even run it as granular as possible. But it will take some time, so have patience if you're running it at a daily data. So I am having a data frame which is resampled monthly. Now, if you see the output, rather than having the data on an hourly basis, now it has monthly basis. That's 01, 02, 03. It is monthly basis, right? So the data is aggregated at monthly basis. Then what I'm going to do is I'm going to split the data. So I am creating a training and test data frame. In the training data frame, I'm taking data from 2012 till 2017 April, and greater than 2017 April, I'm taking as test data frame. So once I run this and quickly check the shape of it, I have 64 columns in 64 rows in train and 4 in test. So from 49,000 odd, I have come down to 64. As I said, I just want the model to complete quickly, so that's why I've reduced it. But still, it's a good way to show the capability of auto time series data. Right now, I have this. Now I'm going to go and create the model. Right. So for me to create a auto time series model, what I'm doing is I'm calling this auto time series function that we imported on the top. I'm telling what is the score I want to evaluate on. I'm telling RMSC. What is my interval of the data? My interval of the data is monthly because it's aggregated in month. If you're running hourly, just give H over here. You can go and read the documentation. The documentation is in this location, the GitHub repo that is mentioned over here. You can go and read the documentation to get more details. And after that, I'm giving some other parameter which are optional, right? So in this case, I'm telling like my non-seasonal PDQ. That is, if you're using ARIMA model, you may be aware of 3 parameters, right? The AR parameter, which is given by P, the high parameter, which is given by D, that is nothing but the difference you want to take in order to make your time series stationary, and the Q parameter, which is nothing but your moving average parameter. I am just giving 212. If you don't give it as defaults to 313, but I feel like for my data this is fine, so I want to kind of bound my data so that it does not really run for all possible combinations and everything. So I'm just bounding to run for max 212. That is a PDQ parameter. I'm telling seasonality is true, because my data does have seasonality. If you see, the demand did have seasonality. And then the model type is I'm giving best. When you give best, it will run all the model you want. But if you want to constrain and run only, say, like Facebook Prophet or a var model or some ML model, you can give that list of model over here. But in this case, I'm going to run for all the models. Right. You can read more about this parameter, as I said, in the documentation. That is the link is mentioned here. That will give you more idea on what are the different parameters. And once I have this model object, I am just calling the fit method. I am giving my train data, that is the train I have on top. I don't want the precipitation column, so I'm just giving timestamp, demand, and temperature. These 3 columns. Now timestamp is going to be my timestamp column. I need to tell which column represent my timestamp. The TS column is timestamp. My demand column is the target column that I want to forecast, and my temperature in this case will be considered as an additional regressor in case of Prophet, or in case of var model, just be an additional feature that will be included in the model. Right. So this is what I'm giving parameter, and I'm telling cross validation 3. So I want to perform 3 cross validation, pick the best model. So once I run this, it's going to start fitting across multiple model. You can see a lot of information. If I give verbose equal to true, it will print a lot of information. You can see over here the timestamp column basically is TS, and all this information is getting printed. It has started with the Facebook Prophet model, and it has started doing like all the cross validation. Once it is done, it will start building the SRE max model. You can see basically over here, it's going to run for all the combination. Internally, it uses the PMD ARIMA package for ARIMA models, and it's going to run all the model. Then finally, it's going to run the VAR model and then the ML model and show you finally all the metrics based on the best model that you have got. So I think it has completed running, and you can see like this is how the leaderboard looks like. You have the ML model which has the lowest RMSE, and then the VAR model. But let's go and print the leaderboard. Once it is complete, I can just say model.get leaderboard, and you can see this is how the leaderboard looks like. Let me again completely get the cross validation score, and here the cross validation score, basically you can see profit, the lowest CV score 167, and then SRE max you have this one, where you have 42, 48, and 700. So because I have given cross validation equal to 3, there are 3 CV scores in everything. Right now you have the model. Now either I can just pick the best model and then do the predict, or I can pick a particular model and do the predict. So for that, what I am doing is I am basically going to, before going there, I can just get the complete ML dictionary that we have got after the model run, and I can go to a particular model, in this case var model on the top, and I can get all the forecast value. So this will give you all the forecast that it has run on the trained data set. It will give you the lower confidence and upper confidence. You can also pass confidence interval as a parameter. I'm not sure if I have passed. No, I did not pass, but you can pass confidence interval as a parameter. In by default, I think it's 95% confidence interval. So this is going to give you this table, but now I need to predict for the future, right? So what I'm going to do for that is I'm going to call the future predictions. I'm going to like create a variable called future prediction. I'm calling model.predict here. In the model.predict, I'm giving the test data frame. Now, since I have given multiple data, you have to pass the data frame. In the sense, I have giving multivariate over here to predict the demand column. I need to give the data frame, but in case if you have univariate, you can also give the forecast interval. You can just give numeric value 4 that will predict 4 values in the future, right? Based on your interval you had given. Right, so that's what I am giving. I'm giving my test data frame here, and then I'm telling like my model equal to ML. So give me the output for the ML model. That's what I'm telling. Like out of the all the model CV scores that we have, and we are going to take the ML model and then do the prediction. Right. So once I run this and get the future prediction, this is how the future prediction looks like. If you see the test data frame on the top, we had 4 values over here, 4,4, that is 4 features and 4 rows, and you will get similar output in your future prediction data frame as well. So this is how the value looks like. Let me quickly see how the test data was. Now the test data was 5421. This is kind of closer, but if you see other values, not much changed, right? But let's try and move to different model. We will use the var model and then predict it and see how it looks like. And if you see the var model, it looks like slightly better. Looks like if you see like it's 5421, it's 5412, 6579, 6116, 7306, little way off. But if you see like the confidence interval in this case, right? See, ML model, there will be not any confidence interval until you create it. But for other models, you can see the confidence interval. Here you can see the confidence interval is between this value to this value. Where there's 7306, you can see is 5731 to 7783. So it's well within the confidence interval is what we are seeing. And the numbers are also pretty close to it, right? Similarly, I can also go and print for the profit model alone. So once I do only for the profit model, you can see basically the entire value coming in. Here is the actual value, then the y at lower and y at upper threshold. So you can see like how simple it was for us to just take the data, run multiple models, and then you can pick and choose your model. You can iterate further if you want. You can add features. Once you know like okay, the var model performs better for this, I can go outside, I can add features. Maybe I can run a separate var model and then see like which coefficients are more significant, and take only those coefficients and build a separate model altogether. I can do all these things, but this gives a quick way of doing hypothesis on our data to see which performs better, and then this easy to even like take it and deploy it further as well. So that's about it. Thank you very much.